Hello friend, welcome to my YouTube channel Electrical Boost. Today we are going to discuss what is self-inductance, and what is mutual inductance. Okay. Before know the what is the self-inductance and what is the mutual inductance. First we know the what is inductance. Inductance is the okay. Inductance is it is a property of material. Okay, basically inductor it is a property of conductor, property of any conductor, electric conductor, okay, which opposes the any change through it and produce some e.m.f, electromotive force. Okay, let's say inductance, the property of conductor that will oppose the any change. That means let this is a conductor, when you apply change in current, it will oppose and produce some e.m.f that will depend upon the inductance, inductance basically two type. One is the self inductance, another is mutual inductance. Basically the inductor or inductance form basically depend upon the coil. If you make a coil or number of turns, then inductance property will be high. Okay, or let us discuss here. First we discuss what is the self inductance. As the name decide, there is only one thing that will self own production. Okay, let's say when there is change in current or magnetic field or magnetic flux, you can say magnetic flux of a coil means conductor of a coil an e.m.f induced this phenomenon is termed as self-inductance. This is denoted by L and unit is Henry. If we apply a change in current in a conductor, if we apply this is a coil having inductance L. If I apply an current I, that will be change in nature. Okay, that is change in nature. Then it have some e.m.f. Okay, this e.m.f produced depend upon the what is the value of inductance. Let we know, according to the Faraday law, this voltage is directly proportional to L di by dt, or you can say di by dt. Voltage directly proportional to the change in current through it. Okay, you can also write V equal to minus L is the one constant, that is inductance, di by dt. Here di by dt is the change in current. Here the negative sign due to the Lenz law. In our previous video we discussed what is the importance of Lenz law. You can see the link in that below. Okay, let this is equation number 1. Okay, let this one. We know that according to the Faraday law, when we apply current through it, I, it produce some flux. Some flux phi. If this current is change in nature, then the flux is also change in nature. Okay, so we can write V is directly proportional to the d phi by dt, or we can write actually n number of turn d phi by dt. Let this is the equation number 2. When you compare both the equation, this equation and this equation, we finally got like this: minus L di by dt equal to minus n d phi by dt. You can write L di equal to n d phi. So we can directly write find L equal to, or self inductance equal to, n phi by I. Here n phi is the flux linkage. What amount of the flux linkage to produce an e.m.f. We know that in Faraday law, whatever the flux linkage, then it will produce some e.m.f. Okay, here the amount of flux linkage, it depends the what amount of the production of the e.m.f. Okay, the n phi is the flux linkage. Okay, this is the self inductance. This is n phi by I. This is the final derivation of the self inductance. Likewise, we going to discuss what is the mutual inductance. In the self inductance, there is only one coil. Which amount of current flowing through this amount of flux is linked with this same coil. Okay, same flux linked with the same coil to produce an e.m.f. that is called self inductance. Okay, next we discuss what do you mean by the mutual inductance. What do you mean by the mutual inductance? Okay, let's start with mutual inductance. Okay, what is the mutual inductance? Okay, first we know what is the mutual inductance, then we discuss mutual inductance. Let this is a coil, okay, where we flow current I. If it produce some flux, let phi 1. If this flux link with the another coil adjacent to it, nearest to it, if this amount of flux link with, or change in flux link with this coil, then it will produce an e.m.f. Let this is phi 1 2. Okay, let this is phi 1 2. Okay, so we discuss. So here we write, according to the Faraday law, we write this V, this e.m.f. produced, V is directly proportional to the di1 let this is I1, okay, d I1 by dt. So we can also write V equal to minus, here we insert the mutual inductance, M is the mutual inductance, okay, di1 by dt, d1 by dt. Let this is the first equation, this is the first equation. Where you write this is, let V2, okay, this is V2. Where this V2 is produced due to the first coil current, so if the first current is changes, then second coil will produce an EMF, okay. This is the mutual, not in self, it will produce EMF by the changes in the current in the first coil, okay. Next we can write as in flux from, okay, we can also write this V2 directly proportional to the what amount, phi 1 2, okay, d phi 1 2 phi, let this is n1, sorry, this is n2, means number of turn in this coil and number of turn in this coil, okay. This is dt, or you can write this V2 equal to minus n2, that means this coil, okay, n2 d phi 1 2 divided by dt, okay. This is the second equation for mutual inductance, okay. If you compare those two equations, these two equations, okay, we got like this, minus m, okay, di1 by dt equal to minus n2 d phi 1 2, that means flux phi 1 link with the coil, the flux from the coil 1 is linked to the coil 2, so that we mention this phi 1 2. The all flux is not linkage, some flux linkage, that is the phi 1 2, okay, so that I mention phi 1 2, okay. Dt, okay, we can also write m di1 equal to n2 d phi 1 2, okay. So we finally mutual inductance you can write n2 phi 1 2 by I1. This is the EMF produced due to the first coil, okay, due to the first coil. If we give the current like this direction, it will like this, what happened, this mutual inductance like this, n1, if you consider this side, n1 phi 21 by I2, okay. Its unit also Henry, in Henry. This is all about self inductance and mutual inductance. There is one chapter is missed, that is the types of mutual inductance. Here you can see the coupling, there is a coupling, okay. What amount of the EMF induced depend upon the coupling, how nearest is coupled, okay. The coupling circuit is two type, we discuss later, okay. Thank you for watching this video. If any doubt in this topic, please comment. Thank you again. Thank you.